All right, we're going to take a look at section 1.4, which is the basic rules of algebra. And the first thing we're going to look at is some definitions. Now, let me remind you, remember, I don't have vocabulary tests, and I don't have put the definitions on the test. But remember, it's good for us to all talk the same talk and have the same language. Everybody can understand what we're saying. So the first definition we're going to look at is a term. A term is a number, a variable, or a product or a quotient of numbers and variables. And terms are always separated. This is how you recognize them. Notice here that we said that in our definition we have a product and a quotient. Product, remember, means multiplication. Quotient, remember, means division. So within a term, you can have multiplication or division. But what separates terms is going to be addition and subtraction. That's how you recognize where terms are. You find the addition, you find the subtraction, and then you find all the terms that are between those. Now, the next definition that we're going to look at is the idea of a coefficient. Remember, we said that within a term can be a number, a variable, or a combination of numbers and variables. So if you have that combination of numbers and variables, the variable obviously is going to be the letter. So then the coefficient is going to be the number part of that term. And then our last definition is going to be the idea of like terms. We keep talking about terms. Well, you can have some that are alike. Like terms contain the same variables, but it's much more than that, because let's say, for instance, that I've got a 4x squared y and a 3xy squared. Well, they have the same variables. They both have an x, they both have a y. Here's an x, here's an x. Here's a y, here's a y. But notice that this x is to the second power, whereas this x is to the first power. Notice this y is to the first power and this y is to the second power. These are definitely not like terms, because there is so much more to like terms than simply having the same variables. They do have the same variables, and those variables are to the same power. Okay, so those are some of the definitions that we need to know. Now, let's take a look at some of our properties. And we're going to start first with our commutative property. The commutative property deals with addition and multiplication. Never applies to subtraction or division. And what the commutative property does is it says, say, for instance, I can take a 2 plus a 3, I'll get a 5. Or I could flip it around and call it a 3 plus a 2, I'll still get a 5. So the commutative property addition says it doesn't matter the order that you add, you're going to get the same result again. With multiplication, it says I can take a 2 times a 3, which is a 6, and I can flip it around and call it a 3 times a 2, which is also a 6. Does not apply to subtraction, because let's say, for instance, I take a 3 minus a 2, I will get something totally different than 2 minus 3. And by the same token, I can take a 6 divided by a 2. I will get something totally different than a 2 divided by a 6. So it does not apply to subtraction, does not apply to division. Does apply to addition and multiplication. So what the commutative property does is it allows us to change the order in which we add and multiply. One of the ways that I remember it is I say that I communicate orders to people. Like, for instance, if I told you to stand up, yeah, go ahead and stand up where you are. You're going to feel kind of silly, but do it anyways. So just stand up. Yeah, stretch out a little bit. There we go. That's good. All right, now let's go ahead and sit down. So what I did is I communicated an order to you, and you followed that order. This is what the commutative property does, is it changes order. You communicate orders. Now, that is different than your associative property. Let's take a look at that. Now, the associative property also applies to addition and multiplication. But what the associative property does is it says, well, what if I take a 2 plus a 3, and then I add a 4? Well, 2 plus 3 is 5, and then if I add that 4, I get a 9. But what if instead I take the 3 and the 4 and add them first, and then add the 2? Well, 3 plus 4 is 7, and 2 plus 7 is still 9. So that's your associative property of addition. Now with multiplication, it says, what if I take a 2 times a 3 and then multiply a 4? Well, 2 times 3 is 6. 6 times 4 is 24. But then what if I flip it around and let's do the 3 times the 4 first? Well, 3 times 4 is 12. 2 times 12 is still 24. So that's what your associative property does. It allows you to regroup whenever you multiply and whenever you add. Flip back here a second. Okay, that's number 2. So it allows you to change your groupings. And just like with the commutative property, it does not apply to subtraction, does not apply to division, only addition and multiplication. The way that I remember this one is I say, well, I associate into groups of people. You hang out with people that you're alike. And typically you associate into a group. And sometimes you hang out with maybe one other person, but a lot of times you hang out with groups of people. So you associate into groups. And so your associative property will allow you to change your groupings. Now, there's a third property that we're going to look at, and it is our distributive property. Often called the distributive property of multiplication. Over addition, but we shorten it to distributive property. Called multiplication over addition because that's exactly what we're going to do, is we are going to multiply. So what I'm going to do, I've got 3 examples here. And let's say first I've got this. And remember, we've talked before that when things sit right up against each other, it indicates multiplication. Well, this 5 is sitting right up against that parentheses. So it's indicating that the 5 is going to be multiplied to the parentheses. But the parentheses is key because the parentheses is showing that this 5 is not just being multiplied to this 4x, but it's being multiplied to absolutely everything inside that parentheses. That's why the parentheses is there. So 5 times the 4x, but also 5 times the 9. Now with 5 times 4x, that's saying I have 4 x's sitting in front of me. 1, 2, 3, 4. And I have 5 sets of that. So here's another set, here's another set, here's another set, and here's one last set. that means that I've got 20 x's. And also notice that 5 times 4 will give me 20. So I have 20 x's. Now 5 times 9 is a 45. So I have 20 x's and another 45. Let's try another example. Let's try this one. With this one, it looks very similar, and once again, the idea is that whenever I've got something sitting right up against, it's going to indicate multiplication. Right up against the parentheses indicates that 5 is being multiplied here, but it's being multiplied to everything inside the parentheses. Now, we established before that 5 sets of 4 x's is going to be 20 total x's because 5 times 4 is 20. We've also established that 5 times 9 is 45, and there's a minus sign between them. Now, notice that in both of these, I did not take the 20x and I did not add it to the 45. I did not take the 20x and subtract 45 from it because they are not like terms. Remember, that definition of like terms said that like terms are going to have the same variables and those variables to the same power. But if you'll notice in both of these examples, this one doesn't even have an x and neither does this one. So they are definitely not like terms. I cannot put them together. Now, let's look at one last example on this one. Notice that in this one, the 5 is in the back. But remember, we said the multiplication was commutative, and that means we can change the order in which we multiply. So that tells me that it's okay to multiply with a 5 in the back. Not a big deal at all. The 5 is still up against the parentheses. It still indicates multiplication, and it still indicates that I'm going to multiply to everything inside that parentheses. So I'm going to kick it back that way. So 5 sets of these 4 x's is still a 20x, and 5 times 9 is still a 45, and I still have a subtraction between them. And they're still not like terms because this 45 still does not have an x. So that's the best that one will get. So that's what your distributive property looks like. And all of these properties are very useful for being able to combine up like terms. So that's the next thing that we're going to look at is combining up like terms. I think 1, 3. There we go. Remember, like terms have the same variables. Those variables are to the same power. So if you have like terms, you can combine them, but what you do is you combine them with addition or subtraction. So you're going to add or subtract, but the catch is you're going to add and subtract only the coefficients. Of those common or like terms. Only the coefficients. In other words, you're going to retain what's making them alike, and what is making them alike is those variables. So since that's what's making them alike, leave it alone. Keep the variables and do what I call work the coefficients. And that's all you're going to do is put together the coefficients. So let's take this example. I have 7 b's, and I'm going to add 3 more b's. That's like saying I have literally 7 b's sitting in a pile in front of me. 1, 2, 3, 4, 5, 6, 7, and I'm going to put 3 more of these b's in the pile in front of me. How many b's do I have now? Well, I've got 10 b's sitting in that pile in front of me. Notice that it's not b squared. I don't want to do that because that's not what I see in this picture. I literally see 10 b's. So my answer is just simply a 10b. Let's try another one here. Let's do a 21c plus an 18c plus a 31b minus a 3b. So what this one is saying is that I've got 21 c's sitting in a pile in front of me, and I'm going to add 18 more c's into that pile. That means I have a total of 39 c's sitting in the pile in front of me. But now with these b's, I've got 31 b's sitting in front of me. I'm taking 3 b's out of that pile. How many b's are left? I've got 28 b's left in that pile. Now, these two are not like terms. This has a c, this has a b. They are not like terms. I cannot put them together. So this is the best that that one will get. And one more. 3j plus 4k plus 2l plus 6k minus 5l. Once again, I'm looking for like terms, and I'm going to combine only the ones that are alike. There's a j, but I don't see any other j's, so I'm not going to combine it with anything. And I see a 4k here. Here's another k. So this is saying that I've got 4 k's in the pile, 6 more k's in the pile. I have a total of 10 k's now sitting in that pile in front of me. And I've got 2 L's, but I'm taking out 5 L's. So it's almost like saying I'm sitting above sea level 2, and I've just dropped below sea level 5, so I am down 3 now, and 3 L's. Now, notice that none of these are like terms. This has a J, that has a K, that has an L. None of them are alike. I cannot put any of them together, and so that's the best that one's going to get. All right, last part here. And that is that we are going to simplify algebraic expressions, make them bigger basically, because what we just had was algebraic expressions. But these are going to be bigger ones. Now what frequently happens is students will tell me, I thought I was done. I thought that thing was as simple as I could possibly get it. You told me I needed to go further, and I can never remember. I don't know when I'm allowed to stop. Well, now I'm going to tell you. An algebraic expression is simplified when all parentheses have been removed and all like terms have been combined. That's when you can stop, when both those criteria have been met. No more parentheses, no more like terms. So, let's do some examples of this. And we are going to simplify each of these. And let's start with this one. 2 parentheses, 2e plus f plus 3f plus 1. Now remember, I have to make sure that all parentheses have been removed. I have to make sure that all like terms have been combined. So first I got to get rid of the parentheses. And we've discussed before that sitting up against always indicates multiplication. This 2 is being multiplied to everything inside the parentheses. Now, am I going to distribute this 2 all the way back here? Right, no, because the 2 is only being multiplied to the material, or to the things that are inside the parentheses, not anything outside of that parentheses. So I'm only going to distribute through the parentheses and up to the end of the parentheses, and that's as far as that's going to go. So 2 sets of 2 E's is going to be a total of 4 E's. And I have 2 F's now because I've got 1 F sitting in a pile and 2 sets of them. That's 2 F's, and 2 E's sitting in a pile. 2 sets of those is 4 E's. Don't forget this 3F and this 1 that are in the back because they're still in the pile. Now we've got to figure out how to combine up all the like terms. We have removed all those parentheses. Check. That's done. But we need to put together all of our like terms. So I see an F and an F here. Put those 2 together. 2 F's and 3 more F's is 5 total F's. But now notice that 4E, that won't combine with anything. And notice also that that 1 won't combine with anything. So that's as good as that one's going to get, and it's done. All right, let's try just a couple more. Make them a little bit harder, because I know you've got this. That's a 4. So we need to simplify yet again, and if you recall, remember that when things are simplified, it is when all the parentheses have been removed and then all like terms have been combined. So let's first move those parentheses, or remove them. Remember, it's okay to multiply backwards. Multiplication is commutative. You can change the order that you multiply. So that 5 is going to be distributed backwards through the parentheses. And like we discussed before, only through the end of the parentheses. It's not going to come all the way back here to this m because it's only being multiplied to what's inside the parentheses. That's the point of the parentheses, is to show what's being multiplied. But when I take this 5 times a 0.6, that gives me 3. And when I take a 5 times a 0.4, that gives me 2. So I've got 3 m's and 2 n's, but remember, don't forget this m that's out front. He's still there. Now, recall that also I need to combine up all those like terms. So I'm going to go through and I'm going to say, well, I have an m and a 3m. Those will combine to be a 4m. Here's that 2n, and remember, these are not like terms because they don't have the same variable, so that's as good as that will get. And one last example, finish this thing off. All right, remember, simplified when all the parentheses have been removed and then all like terms have been combined. So I'm going to remove the parentheses first. I'm going to distribute the 4 through. Remember, only to the end of that parentheses. I'm not going to distribute beyond that. So 4 times 2a is 8a. 4 times b is going to be 4b, and there's a subtraction between the two. Now I'm going to pick up my 2, and distribute it through the parentheses and through the ending parentheses. So now I have 2 sets of a, and I've got 2 b's, but 2 sets of those. That gives me 4 b's. So I removed all those parentheses. Now I just got to go through and combine up my like terms. 8 a's and 2 more a's will be a total of 10 a's. And now with those b's, I'm going to have negative 4b and 4b. That's like saying I got 4 b's sitting in front of me and I'm taking 4 of them out of the pile. I've got no b's left. They're going to cancel each other out completely. And sometimes that happens. That's okay for things to cancel out completely. That 10a is all that I'm left with. So that's everything that you need to know out of section 1.4. You're good to go with that. And be sure you get into my math lab and practice.